All right, welcome back, everyone. This is TSI Math Crash Course Day 1, Part 2. We've been working on fractions and comparing fractions and operations with fractions and a little bit with decimals, and now we're kind of combining it all together, including some percents here. So, Jackson, I would love you to read question number 14 for me, please, loud and proud. And we'll approach it logically here. Go ahead, read the question.
All right. Which of the following correctly orders the values above from least to greatest?
From least to greatest. We got to know what the smallest is, and then we got to know what the biggest is. Interesting. Okay. Now, this question here introduces something we haven't talked much about yet: percents. All right, we got this percent here. This. How would we read this number right here?
75%.
Nope.
Oh, 0.75%.
0.75%. 0.75%. Jackson, is 0.75% bigger than 1%, or is it smaller than 1%?
Smaller than 1%?
It's smaller than 1%. You know what I'm saying? 1% is pretty small, right?
Right.
1% is pretty small. Like if you got 1% of the questions right on a test, you might get one right out of 100. Not a whole lot. Right? So if you got 0.75% on an exam, that would not be so great.
No, it would not.
No, it would not. Okay, that's pretty small. And again, like I want you to make these real, make these concrete.
Yeah.
You know, that's less than 1%, which isn't much. Okay, let's talk about percent real quick. Okay, do you know what percent means? And I know you know kind of in general what a percent is, but you know what it means, the word.
Percent per
100? Per 100, exactly. Per 100. Right? Like there's 100 years in a century. Right? That's what I call a century. There's 100 cents in a dollar. Right? So cent means 100. So per cent means per 100. Okay? That's why 50%, right? And you know 50% means half, right? It means half because it means 50 out of 100. And if you reduce that fraction, you get 1/2.
Mm-hmm.
Does that make sense?
Yes.
So to find a percent, all we got to do is take that number and put it over 100 as a fraction. Does that make sense?
Yes.
Okay, good. Therefore, 0.75%, really small, that's the same as 0.75, less than 1 over 100. That's pretty small, right?
Yes.
Okay. Do you know how to express 0.75 divided by 100 as a decimal?
0.75 divided by 100 as a decimal?
Yeah.
No, I don't.
Yeah. Let's talk about this. Let's find 7% first. Not point. Let's find regular 7%. Okay. 7%. Right, we're talking like 7.0, right? 7%. How do we describe 7% as a fraction?
So 7 over 100.
7 over 100, exactly. Okay, 7 over 100. Now, if we were dividing 7 by 10, we just take the decimal point and move it over one space, right?
Right.
And it would be 0.7 if it were to be divided by 10. But it's not being divided by 10, it's being divided by 100. So we have to move it over how many spaces?
2.
2 spaces. Right?
Wait,
So that becomes 0.07. It's 7%. Does that make sense?
Yes.
Okay. Please understand that. 0.07 is the same as 7%. Which makes sense, right? Because like 50% is 0.5. Right? 10% would be 0.1. 7% then is 0.07 because 70% would be 0.7. 70 over 100. Oops. which is equal to 0.7. Does that make sense?
Yes.
Okay, good. You gotta be comfortable with percents here. It's gonna pop up a lot on the TSI and other standardized tests. They like testing on percents. Okay. So the question is, how much is 0.75%? Well, let's find out what that is. Let's find out what 0.75 divided by 100 is. How many times are we gonna have to move that decimal place?
0.75 divided by 100.
Yeah. How many times are we gonna have to move that decimal place?
2 to the left.
2 to the left. 1, 2.
0.0075.
Yes, exactly. 0.0075. How does 0.0075 compare to 0.075? Which one is bigger?
0.0075 compared to 0.75. So, are they the same size?
Well, look at them.
So 0.075 then.
Is bigger.
Yeah.
Than 0.75. Does that make sense?
Yeah. I think.
Right. I mean, the more places away from the decimal place to the right, the smaller the number. Like 0.000001 is smaller than 0.1.
Yeah. It is.
Right. And because we got 2 spaces here away from the decimal point, that's smaller than this guy that only has 1 space away from the decimal point. Does that make sense?
Yes.
Okay. What's the right answer choice here?
From least to greatest.
Well, let's start. Look, let's start here. Can we recognize what the biggest number is? What's the biggest number of those 3?
3/4.
3/4 by far.
Yeah.
Because that's 0.75. That's almost 1. Right? And 0.075 is pretty far away from us. That's not even 1/10, let alone 1. So we can eliminate 2 answer choices easily. Which ones can we eliminate? That aren't from least to greatest.
That aren't from least to greatest?
Yeah. Because the greatest has to be 3/4.
We can eliminate B.
Yeah.
We can eliminate C.
Yeah, because 3/4 isn't the greatest there.
Yeah.
Make sense?
Makes sense.
And again, maybe we should have started there. Recognizing that. Yeah.
So I'm gonna say we can eliminate A too.
Yeah. Because didn't we just say though that 0.75% is smaller than 0.075?
Yes. We did.
It is, right? Because 0.75% is the same as 0.0075.
Yeah.
So it would be A, actually. Oh, wait. Yeah, it would be A, because that's least to greatest.
Yeah.
Does that make sense?
Yes.
That's tricky. And what throws it at you off is that you want to look at that 0.75% as 75%, but it's not. It's not 75%, that's 0.75%. That's less than 1%. That's less than 1%. And 1% is 0.01. Which is and 0.01 is even less than that, 0.07. It's like 7 times less than 0.07. Woo! That got a little bit hairy there with the percents, right? Can we agree? That's a little complicated there. But at the very least, you can eliminate B and C pretty easily, recognize that 3/4 is the biggest.
Uh-huh.
And then you got a 50-50 shot. I'm cool with that. Very cool with that on a tough question like this. I would really not expect most kids to get this. But you got to have a really good handle on percents there. We're not done with percents either. We're going to come back to this. Let's look at this guy here. Question number 10. Go ahead and read question number 10 for me, please.
What is the value in 3.85 plus 0.004 plus 117?
Yeah. Okay. I think, look, can we recognize that .004 and .117 are just not very big?
No, they're not.
Not at all. We should be able to eliminate one answer choice just right off the bat, just basic estimation. It's not even going to be close to that.
So we can eliminate D.
Absolutely. Right? I mean, we'll be lucky if this is over 4. And I don't think it is. Certainly not over 5. Come on.
Yeah.
Right? D's gone. Even if this is as far as you get, you got a 1/3 chance of getting it right now, which is better than 1/4.
So, first off, I guess what we can do,
Yeah,
I think, is we can just add the .004 and .117 together.
We can do that. Before we even do that, though, and you're absolutely right, we're going to do that in just a minute. Do you think we're going to have a lot of decimals in, like, a lot of numbers after the decimal point in this answer, or not many?
We're going to have a lot of decimals?
Yeah, are we going to have a lot of numbers after the decimal point?
I think we're going to have, like, a couple.
At least a couple.
Like, at least 3.
At least 3? Yeah. Let's do this. Are we going to have 4?
I don't know yet.
I don't know. Let's just add them. Let's add them. Okay. Here's the trick to adding with decimals. You need to keep the decimal spot in the same place. Okay? So we don't like to do the .004 like that. No. No way, Jose. We got to rewrite it, but keep the decimal spot right here. So 0.004. Okay? And just for the sake of clarity, I'm going to add a 0 right here. Because 3.85 is the same as 3.850.
Yeah.
Right? Now, you tell me, what do I do with that .117? Where do I put that?
Just right there.
Where? You do it. You add it.
Just point the decimal.
You do it. Do it. Do it on the whiteboard.
Okay. Has to refresh.
Yeah, no problem. You might need to zoom in or out. I'm not quite sure. As I've been working this stuff out. Do you see the question on the whiteboard or no?
Yes.
Okay, good. 0.117. Okay, good. And then let's add them up.
Okay.
Yeah. I think I already know the right answer. What's the right answer choice?
So, C.
It's C. Absolutely. It's C. Now, just looking at these, like, I see, like, there's no decimal greater than 3 places to the right, or no number greater than 3 places to the right of the decimal. Right?
Mm-hmm.
So I'm looking at answer choice A, I'm like, dude, there's 4 digits to the right of the decimal. How am I going to get a 1 that far away from the decimal place? That's 4 places away. That doesn't make a whole lot of sense. So just again, thinking in logical terms, I don't think the math or the calculation is too complicated here. As long as you got to line up those decimals. Right, that's the key. Right. But that's not too bad, is it?
No.
Okay, but I like, again, right off the bat, you could eliminate D. Just really, really silly.
Yeah.
Okay. All right. Do we have more? Ooh, I like this one a lot. We got some questions of decimals coming up here. All right, go ahead and read question number 13 for me, please.
Okay. A machine is currently set to a feed rate of 5.921 inches per minute. The machinist changes this setting to the 6.088 IPM. By how much did the machinist, yep, increase the feed rate?
Okay. Before you start freaking out about math, And operations. Let's think about this one just logically, man. Let's think about it logically. This is a real world situation. Did the machinist increase? Okay, he obviously increased the feed rate. Did he increase the feed rate by more than 1 inch per minute?
Yes.
Goes up from 5.9 to 1. I'm going to round that just to 5.9. Okay? I'm going to round that. Sticks up from 5.9. Let's think in terms of money again. Let's think in terms of money. You got $5.92. And then you get more money. Now you've got $6.09. I'm rounding up. Is that more than $1 increase? From $5.92 to $6.08. Is that more than $1? What's that?
I would say no.
No. Because if it was $1 increase, you'd go from $5.92 to $6.92. That'd be $1 increase. Right?
Right.
Again, you got to make this concrete, man. Don't get lost by all those numbers.
Yeah, so...
Like, these are values. They have meaning.
It's not that much of an increase.
It's not much of an increase at all.
So A.
It's A! Done.
Yeah.
Done. Does that make sense?
Yeah.
Logic, man.
Logic.
Don't get overwhelmed by numbers. It's so funny. Like, students forget that numbers have meaning.
Mm-hmm.
Apparently, you need to just think in terms of money all the time.
Yeah.
5.9 is almost 6. And 6.088 is just barely above 6. This is not even a 1 inch per minute increase. Not even close.
Yeah.
So it can't be B, C, or D, which it's not. I mean, we could talk about what they want you to subtract the smaller number from the bigger number. We could do it. Do you want to do it? It's probably worth practicing the operation.
Subtract the smaller. Okay, yeah.
Yeah, to find out what the change is, right? And let's do that. Let me see you set that up. I want you to take the bigger number and subtract the smaller number from it.
Okay, so on the whiteboard?
Yeah, that'd be good.
Okay, so 6. 9.
Yeah, the key to adding or subtracting with decimals is lining up the decimal.
Subtract?
Yeah, you got to subtract them, right? Because that's going to tell us the difference between the two. Does that make sense why that'll tell us the difference?
Mm-hmm.
Yeah.
Yes.
Yeah. And 8 minus 2 is 6. Okay, now this is tricky, right? What's 0 minus 9? You can't do. You got to have to borrow from the next place over, right? Right? Do you know that operation or no?
I think it.
Like,
yeah.
Turn that into a 5,
5,
and then this guy becomes a 10. Yep.
1.
And then, there you go. Which is the answer? Which is
the
answer choice A. But again, you could just feel that one out with some basic estimation. And easily eliminate B, C, and D. Okay?
Yeah.
I like that first way better. I'm guessing you do too.
Yeah. I do.
That's the way to look at it, man. That's the way to look at it. Now again, you know the operation great and you want to confirm it, wonderful. But you don't even need it here. Don't even need it. Do you see what I said earlier? It's not a math test.
Yeah.
Just logic.
It does have a lot of math on it, though.
Yeah, I mean, there's math. There are math properties. But and math concepts. They test you on math concepts, but not math operations. Not necessarily. Okay. Go to read number 16 for me, please. We're talking more properties of decimals.
All right. What is 0.86 37 rounding to the nearest hundredth.
Yeah. Do you know the names of the places after the decimal place?
I think it's like hundredth, thousandth, tenth, hundredth, and then thousandth.
Yeah.
Right?
Yep, that's tens. And then the 6 is the hundred. I'm going to write hundred. And then the 3 would be thousands. Sorry for the awful handwriting. And the 7 would be the 10,000th. I mean, you're just going backwards, kind of. Tenths, I should say. Hundredths, thousandths, 10,000ths. All right, so we need to round this to the nearest 100. How would we do that?
Excuse me?
How would we do that? How would we round this number, this decimal, to the nearest 100th?
Okay, so would you just round the 6 up to a 7?
Well, do we need to go up or down? Do you remember how to do it?
I'm not sure.
Yeah. What you do is you look to the digit to the right of it. And if the digit to the right is 5 or bigger, you round up.
Okay, yeah.
Right? And again, like, dude, think about money, man. Think about money.
No, I know how to round.
Yeah,
Just
yeah.
like a big number you read up. I was just confused on what you wanted me to round.
Oh, gotcha. Yeah. Yeah, so we're the 100th is we're rounding this. We're going to round to 2 digits.
Yeah.
So are we rounding up or down here?
Down.
Right, because 3 is, well, not 5 or bigger. So what's the answer?
So would you just round it down to 5?
No. No, we're not decreasing it. And not decreasing the 6, I should say. If we're rounding down, when we say rounding down, we're going from 8 or 0.8637 to just 0.86. We're just going to leave it.
Oh.
We're just going to leave it.
Okay.
If this were a 5, then we'd go up to 0.87.
Okay.
But because we're rounding down, we're going to round down to 0.86, which is less than 0.8637. That's why we call it rounding down. But we're not going to decrease the 6.
No.
Does that make sense?
Yes.
Yeah, we just kind of end it. We just end it there, basically.
Yeah.
So, and that's it. It's answer. Now, there's 2 things. They first look. They want you to know what the places are. It's tens, hundreds, thousandths, 10,000ths. And just by knowing that we're rounding to the nearest 100th, it's going to be 2 decimals, so we can eliminate 2 answer choices. We can eliminate B and C because those are to the thousandths place. Just knowing that, right?
Right.
Just knowing that, just knowing the places. Then it's a question: do we round up or down? And we round down. It's 0.86. Okay. Any questions about that?
No.
Nope. Okay. That one you just gotta know. But yeah, that's okay. So that's a math question. I have to admit. You just got to know what that mathematical term means and what that mathematical operation is. It happens. Okay. Let's do this guy. I like this. Go and read question number 1 for me, please.
Which of the following fractions is equal to 0.06?
0.06. Let's make it concrete again, man. How much money are we talking about? How much
6
money?
cents.
6 cents, man. 6 cents.
6 cents. So 6 100ths
Yeah.
to D.
Yeah. That's it. I mean, 6/10, 6 over 10 would be that's bigger than half, right? And half of a dollar would be over 50 cents. So it's not C. B is tempting because that's pretty small. You know what I'm saying?
Yeah. It's 1 over 60.
Yeah.
And
Yeah. It's pretty small. But it's not 6 cents. That would be less than, like, 1/60th of a dollar would be less than 2 cents. Because 1/50th of a dollar would be 2 cents. Right?
Right.
1/50th, because 1/50th would be 2 over 100. That's less than
Yeah.
2 cents. Yeah, I'm just kind of like feeling that out. And then 1/6, would that be more than 10 cents or less than 10 cents of a dollar? 1/6 of a dollar.
I don't know.
Well, 1/10 of a dollar would be 10 cents, right?
Yeah.
And it's 1/6. Is that bigger than 1/10 or smaller than 1/10?
I think that's smaller than 1/10. Actually, so, like, 1/5. Would 1/5 be bigger than a 10th?
Yeah, 1/5 would be bigger than a 10th.
Okay, so we can probably say that. No, I think that it's smaller.
No, you're right at first. It's bigger.
Oh.
And we can confirm that with finding a common denominator, right? Let's multiply that by 10 over 10.
60.
Multiply that by 6 over 6. We get 10 over 60 is greater than 6 over 60. I don't know if that helped at all. I'm just trying to estimate these, like what these values mean. You know what I'm saying?
I couldn't really see it in my head. So.
Yeah, that's okay. That's okay. But again, honestly, like the last skill that we went over about like knowing the places, like knowing that this means 6/100ths, right? Not 6/10ths, 6/100ths, right? And one of the answer choices is literally 6/100ths, which is answer choice D, which is another way to look at it. Maybe even a better way to look at it. Right? Does that make sense?
Yes.
Yeah, okay. But I love it. Like right off the bat, you pretty much knew what it was, which is good. Okay, we have to do an operation here. Okay, that's okay. We're going to do it. Or do we need to? Haha! Go and read number 15 for me, please.
Okay. What is the value of 2.84 times 3.9?
Do you know how to multiply fractions or multiply decimals?
Yeah.
Okay.
Yeah.
Well, I got good news for you, Jackson. I don't think we even need to carry out the operation here. I think we can use some basic logic and some basic estimation to find the right answer.
Okay.
What's 2.84 close to?
3.
It's really close to 3. And what's 3.9 close to?
Really? 4.
Really close to 4. Right? You see where I'm going with this?
Yeah.
What's 3 times 4?
12, so it's close to B.
It's B.
It is B.
It's
yeah.
B. That's it. I mean, look at A. That's 4. That's less than 3.9. We're not going to multiply 3.9 by something bigger than 1 and get something less. A's gone. That's silly. Answer choice C, 34? Come on.
Yeah,
Way too
it's
big.
not even practical.
Not even possible. With basic estimation. Does that make sense?
Yes.
And again, this is where, like, yeah, sometimes you got another operation here. Just basic estimation is good enough. It's not a math test. It's a logic test with mathematical concepts. Okay? Do you want to go over the operation here? It's probably worth reviewing.
Yeah.
Yeah,
Sure.
let's do it. And just for the sake of time, and I'm more comfortable with the whiteboard, I'm just going to show you and anybody watching the recording how to do it. The key to multiplying decimals is not so much lining up the decimals, you don't have to. It's knowing how many decimals are to the right, or how many digits are to the right of the decimal place. Okay, let's see if I can. Woo, it's been a couple days since I've done. Okay, all right, guy, I need you to check me here. I'm the king of silly mistakes. All right, so 9 times 4 is what?
9 times 4 equals 36.
Yeah, 36. So 6, 3. And then 9 times 8 is what?
9 times 8 equals 72.
Yep, 72 plus 3 is 75. So we put 5 there, 7 here. And 9 times 2 is what?
18.
18 plus 7 is 25. I'm not worried about decimals yet. We're going to get to that. Okay, now I'm moving to the next space over. I've got to draw that 0. All right. Now I'm doing 3 times 4 with 3 times 4.
12.
12. I'm going to erase the digits above. 12. So I'm going to put a 1 up here. 3 times 8 is what?
3 times 8 equals 24.
24 plus 1 is 25. I'll put the 2 right here. 3 times 2 is what?
6.
6 plus 8, or 6 plus 2, which is 8. I'm going to add these up. 6, 7, 0, 1, 11. Okay, now here's the key. We got to find how many digits are to the right of the decimal point. And we got 3 digits to the right of the decimal point. So we're going to have to move 3 spaces to the left. 1, 2, 3. That gives us 11.076, which is answer choice B. Woo!
All right.
I'm going to zoom out a little. There we go. I like the first way, though, better, don't you?
Yes.
So much better.
So much better.
Yeah. Basic estimation, man. That should be your go-to. Start there. If you can't figure it out with the logic and the estimation, okay, carry out the operation, but you're pretty much going to get it if you can just estimate it there. Okay. Ugh, we have to do an operation here. Ugh. Boy, I want to skip that one. I'm not gonna. We got to do some math here for this guy. Go to equation number 12 for me, please.
Okay. What is the remainder when 599 is divided by 9?
Yeah. Do you remember division? Long division?
Yes.
You remember to set this up?
Yes.
Can I see you do it?
Yeah.
599 divided by 9. We're going to get a remainder here. I don't think it goes equally into 9. Or 9 doesn't go equally into 599. But let's go through it.
Sure. And you want me to do the problem on the board?
Yeah. Before we do that, I want to look at this logically. Because I'm just looking at it right now. Can 9 go into 599?
Yes.
Like evenly?
Probably not.
I don't think so, right? Because like, I don't know, and maybe you can't. Maybe it's not easy to think in those terms. I mean, it goes into 99 great, but it doesn't go into 500 evenly. Because 9 doesn't go into 50 evenly. So it's not going to go into 500 evenly. I would eliminate A right off the bat. You know what I'm saying?
Yeah.
Like it just doesn't fit well into 599. And then I don't think it's going to be 9 either, because you can't have a remainder of 9. Like if there's a remainder of 9, that means like it would fit. I mean, like it could fit a whole nother time in. You know what I'm saying?
Yeah.
You're not going to have a remainder of the thing you're dividing by.
Mm-hmm.
Not going to happen. If this is as far as you get, you could eliminate 2 answer choices. But let's go through the operation. Let's do it.
Okay. So 9 times 5. Times.
Yeah, so the question is, does 9 go into 5?
9 times 54.
Yeah, 9 times what is 54?
6.
6, exactly. So where do we put that? You're right. Where do we put the 6? Do you remember? If not, I can guide you through it.
Didn't I put it up there?
Oh, I'm sorry. Maybe you are working on another. Oh, ha, ha, ha. Yes. I'm sorry. I was over to the right and you were over to the left, but I see you now. Yes, good. All right, so 9 times 6, 54. Yeah, minus, and then you subtract 9 minus 4 is 5, so 59. How many times is 9 going to 59?
9 goes into 59 6 times.
6 times again.
So 54 again. And then we're going to get 5 again.
Yep.
And then you have to drop down to 0.
Yeah, you could get a. Well, I'm going to stop you for just a minute because you're going to get a decimal here, but they want to know the remainder.
Yeah.
So it's not going to be expressed in a decimal. The reminder's 5. The reminder's 5. Yeah. I mean, it's what you got right here. It's what you got left over. 9 can't go, evenly into 5 any times. So the reminder's 5. Does that make sense?
Yes.
Yeah. Okay. Long division, buddy. Woo! Has it been a while since you've done that or no?
No, not.
You've done it recently?
Yeah.
Good. Good, I'm glad. Yeah, sometimes you just got to know the operation.
I think I use long division a little bit.
Okay, good.
Something you use a lot.
Good. Well, you're going to be good on a question like that. Percent of total. Yes. Question number 5. Go ahead and read it for me, please.
Okay. A store stocked 150 cans of popcorn for a weekend sale. That weekend, 72 cans of the cans sold. 72 of the cans sold. What percent of the cans of popcorn stocked were sold that weekend?
Okay. Let's think about this with just basic logic, man.
Mm-hmm.
Basic logic. Basic estimation. If you're going to guess what, don't even look at the answer choices right now. If they've got 150 cans of popcorn, they sold 72 of them. Like, what percent roughly is that?
Roughly?
Yeah.
Half?
Roughly half, which is what percent?
5%? No.
Well, let's think about it.
48%.
Yeah, I mean, half is 50%, right? Like, if you get something's half off, it's 50% off, right?
Yeah.
Half is 50%.
Right.
Not 5%. 5% is like 1/20th. Right? If I'm like,
Yeah.
I'll give you 5% off. Like, is that a big discount?
No, it's not.
Not so much. Right? You're like, thanks a lot. 5% off. Oh boy. I mean, I'll take it. But 50% off, ooh. You see where I'm going with that?
Yes.
What's the right answer choice, man?
40. C.
Done. Basic estimation. It's good enough.
Mm-hmm.
It's good enough. It's good enough. And we could confirm it. We could multiply. And now remember, this it's just like the fraction one, right? Where if we're talking about a fraction of something, we're multiplying by that fraction. If we're talking about a percent of something, we multiply that by that percent. So we could confirm this by multiplying 150 by 0.48 and seeing what we get. That'll tell us what 48%. Remember, because 48% equals 0.48. 48%, sorry. Equals 0.48. Does that make sense?
Yeah.
48% is the same as 0.48. So let me see you do that, actually. Let me see you multiply that 150 times 0.48. Let's see what we get. It's going to be just a little bit less than half. I'm going to make that decimal point really clear. We don't want to lose a decimal point.
Yeah.
Good? Looking good? And that's a 0 right here. Right? Yeah. Just gonna make it real clear. Yep, you're good. All right, and then we're going to do the next space over, so we got to add the 0. I'm going to stop you real quick. Stop. Yikes, I don't like where you put that 0. No me gusta.
It's a little bit to the right.
Yeah, or to the left, I think. Well, okay, you're just leaving the blank space right here. I always draw the 0 at that spot and then move over. You know what I'm saying?
Yeah.
But if you want to just move it over, that's fine. I see what you're doing. Okay. You're good.
Well,
you just leave it blank and you go to the next space over. That's fine. That's fine. I always draw the 0 there, but you can leave it blank. Whatever. We did something wrong.
Yeah, I did.
We did something wrong. Let me check. I'm just over here to the right because I didn't quite catch. I didn't follow all the steps you're doing. I'm gonna work this one out if you don't mind. Over here. Do you see where I am? Just to the right.
Yeah.
Okay. I'm gonna work this one out. So 0 times 8 is 0. 8 times 5 is what?
8 times 5 equals 40.
It's 40. So we've got a 0 in the denominator and a 4 right here. Or 0, as you said, 0 down there. And then 8 times 1 is 8, plus 4 is 12. Okay. Now, I always draw the 0. When I'm moving from this space right here to this space. So I draw the 0 right off the bat before I do any calculations. 4 times 0 is 0. 4 times 5 is 20. So 0, and that becomes a 2 up there. 4 times 1 is 4, plus 2 is 6. So I think you didn't add a 0 somewhere in like this spot. That's the one you missed, right?
I see where I went wrong.
Yeah, but again, this is why I love doing basic estimation, because there's nothing to mess up. Like there's no calculations to mess up if you're doing basic estimation. You know what I'm saying? Like the way we solved it the first time. And then the key, we've got two digits to the right of the decimal point, so we move the decimal point 2 spaces over. That's 72. So we could confirm answer choice C. Okay. Does that make sense?
Mm-hmm.
Okay. That's why if you can avoid the operation and just use basic estimation to do it, I recommend it. There's nothing to mess up. Because otherwise you try to find 2% of 150, and I mean if nothing matches up, then you're like, I'll just guess. But I mean, you'd be silly to pick answer choice A. Because 72 just isn't 2% of 150. It's almost half. It's almost 50%. So pick the one that's close to 50%, which it is. Okay. Almost done here. Aha. Go to your question number 7, please.
Okay, if Manuel deposits 25% of $130 into a savings account, what is the amount of his deposit?
Jackson, let's approach this one logically, man.
Okay.
Let's approach it logically. If you're going to estimate what 25% of 130 is, don't even worry about calculations or anything like that. What would 25% of 130 be? What do you think?
32.50.
Probably something like that. I mean, I guess you're looking at the answer choices, right?
Yeah.
That feels about right. Because what's 25% of 100 would be 25, right?
No. Yes, for 25 of 100.
Yeah, 25% of 100, right? So it's probably not B. I mean, look at A and D.
Yeah, those are completely crazy.
Those are crazy. The only ones close, it's either B or C.
I think it's C.
It's C, man.
Yeah.
It's C. How great is that?
Pretty great.
You don't even need to carry the calculation. I don't recommend it. I don't. If you can avoid it. If you can use basic logic, basic estimation. You're not going to mess it up. You're not going to mess it up. Let's carry out the calculation. Again, there may be some circumstances where you need to, so let's practice it. Let's find 25% of 130. Again, if you want to find the percent of something, just multiply by the percent. What's 25? What's 25% as a number?
25% as a number?
Yeah. What does 25% equal? It's going to be a decimal. Right? Remember, because it's just 25 divided by 100. Right? 25% is 25 divided by 100. So what's that?
25 divided by 100 equals I have a blank brain right now.
Yeah, you're good. You're good. We've been mathing for like 2 hours. So you're good. Remember, there's 2 zeros, so we're going to move the decimal place over two spaces.
Yeah.
That's it. So it's 0.25. Which makes sense because 25% is a quarter a whole. Or 1/4.
Yeah.
I mean, think about it. 25% of a dollar is 25 cents. Right? So then you can multiply that 130 by 0.25. Can I see you do this?
Yeah.
Let me see you do it.
Oops.
Looking good. Well, hold on. Okay, you're good. I see what you're doing. You're good. Beautiful. We got 2 digits to the right of the decimal place, so we move the decimal over 2 spaces, 3250. Beautiful. We confirmed it.
Awesome.
Yeah. But the first way is better, isn't it?
Yeah, it is.
I mean, look at the rules. You see why I've got the rules the way they are.
Yeah.
Start there.
Okay.
Start there. You're probably more likely to get it. You can confirm it with the math, if you're feeling it. But you don't even need it.
Well, and if you still want to use the actual math process, then if you're sure of what the answer is, then it's gonna help you guide your problem.
Exactly. Yeah. Absolutely.
Yeah.
All right. Yeah, if you're planning on taking the TSI, I recommend taking it not long after this course, because you're thinking about things in the right terms right now. You know what I'm saying?
Yeah.
But then, if you go back to your math class, you start thinking about math operations again. So I'd recommend taking it not long after, in 3 weeks from now, 4 weeks from now, if you have the opportunity. While all these strategies and approaches to the questions are fresh. Let's do this one. Same thing.
Okay. 60% of what number is equal to 30?
Okay. 60% is close to what percentage?
60% is close to what percentage?
Yeah.
Close to 50.
It's close to 50, right? It's just a little more than 50.
Yeah.
Well, 50% of what number is equal to 30?
50% of what number is equal to 30?
Yeah, just logically. 50% of some number. Half of some number is 30, right?
Half of some numbers. Half of 60.
Half of 60. Yeah.
Yeah. Yeah.
Yeah. Right? Just
Right.
estimating this. Look at the answer choices, man.
Okay. So 60% of 60 is equal to... No, 50% of 60... No.
You got it. You got it. What's the right? Look at the answer choices, man. Right. I mean, 60% is almost half, or it's bigger than half, right?
Yeah.
So the number, we're trying to find what number. 60% of what number? It's got to be, that number has to be bigger than 30, doesn't it?
Yeah.
Look at the answer choices, dude.
50.
Yeah. Right? I mean, it can't be. Look at A. 60% of 0.5, that's going to be less than 0.5.
Okay.
Right?
Right.
Gone. 60% of 2, that's going to be less than 2.
Appreciate it.
It's not going to give you 30.
Yeah.
Answer choice C. 60% of 18 is going to be less than 18. It's going to be close to half of 8. It's going to be like 9 or 10. It's not going to give you 30. Right? But when you're just kind of feeling so like, okay, 50% of like 60 would be 30. So probably It's going to be something close to 60, which is D, and it is. We can confirm it if you want to, right? We're talking about some percent of some number. So let's do we'll do 60% of 50. What's 60% as a decimal?
What's 60% as a decimal?
Yeah. What is it?
0.6.
0.6, exactly. 0.6.
Oh, great.
Not 0.06. 0.06 would be 6%.
Oh, yeah.
Right?
Yeah. Well, because you're moving the decimal 2 to the left.
Exactly.
So it's 0.6.
Exactly. I love it. I love it. You're catching it. You're catching on. Absolutely. 0.6.
All right.
Right? So we're just multiplying by 0.6. Do that. Let me see the operation.
Okay.
Well, hold on. What's 6 times 0? Let's start there.
What's 6 times 0? It's...
You're good.
Oh, my gosh.
You're good. We've been doing this for about 2 hours, so you're good.
Yeah,
and then we got one digit to the right of the decimal point, so yeah, there you go. So 30. Perfect.
Wow.
Yeah. You can do this, dude. You're doing it.
Yeah.
You're doing it. How do you feel?
I feel like more refreshed. Definitely.
Good.
Like math that I haven't done in a while.
Yeah. Good. For homework, I've got just a couple extra, like 3 questions that you haven't seen yet that I want you to try. They're word problems. Again, think in logical terms. That's what I want you to do. I'm also going to recommend. I'm going to send an email with the video, the links to the videos, so you can review anything you need to review it. If you need to go over percents again or some operations with fractions, do that. I want you to try solving all the questions on your own again. Okay.
Okay.
Try solving them on your own. And for anybody watching the recordings, same thing. Try them all on your own. And if you don't remember how to do it, you don't remember the operation, don't remember exactly how to think about the question, how to approach it, then review how we solve the question in the video, and then try to solve it again on your own. But let's take the skill set and really solidify it. Does that make sense?
Yes.
Okay. Jackson, you have any questions for me?
No, sir.
No. Okay. Awesome. Thank you so much for meeting with me today. Really glad you could make it. And would you plan on being in class next week also?
Yeah.
Okay.
Yeah, definitely.
Great. Well, I look forward to seeing you then. Okay.
All right.
All right. Thanks so much, Jackson.
Thank you.
Okay. Take care. Bye.